Hello and welcome to this week's episode of Healthy Innovators Live TV. My name is Barry Shrier and I'll be your host for this week's episode. These weekly TV shows are sponsored by Giant Health. Giant is a global community of nearly 200,000 people around the world whose business is healthcare, technology, and innovation. I'd also like to thank our sponsors, which include McKinsey, our knowledge partner, Barclays Bank Eagle Labs, and Vodafone Business. Thank you very much for all of our sponsors. We love working with you guys, and we're grateful for your valuable support. I'd also like to thank the many tens of thousands of viewers who dial in to watch these weekly episodes of Healthy Innovators TV every week. We appreciate your support. We're keen to make sure that the programs we present to you are interesting and educational and fun and valuable. So please don't hesitate to contact us. If you have any suggestions regarding TV episodes, please contact us. Our website is www.giant.health. Lastly, I'd like to remind everybody that coming up next week, we have European Health Tech Innovation Week. This is 5 one-day conferences taking place across leading cities and healthcare ecosystems in Europe. On Monday, the showcase event is taking place in Liverpool, in England, and we invite anybody who's interested, once again, to come to the Giant website, www.giant.health, and check out European Health Tech Innovation Week, starting this Monday, 17th of May in Liverpool, England. Anyhow, this week, I'm very, very proud to introduce you to Janet Hemingway. Hello, Janet. How are you?
I'm very well, thank you. Yourself?
Very well, thank you. Janet, we're very proud to have you on board. You've had an incredibly impressive and illustrious career, and certainly very grateful for your time and looking forward to our conversation. So if it's okay with you, we'd like to dive straight into it. If you can give us an example, what's a big challenge in society or a big challenge in healthcare, which is present right now that we're taking steps to address?
Well, certainly everybody's living through these extraordinary times with the COVID pandemic. But even before that, one of the huge grand challenges that we've had in health, certainly in infectious diseases, is how we get new therapeutics to the market more quickly, more cheaply, and more effectively than we do at the moment, because the system's been broken for quite some time.
You say the system's broken. First of all, could you explain what do you mean as a simple example of a new therapeutic, in case there's anybody in the audience who isn't of a medical or pharmacy industry background? And then I'd love to hear more about your observation. You say the system's broken. So what are examples of that? If you could tell us more, please.
So a therapeutic I'm using as a very broad term.
Okay.
It could be a new antibiotic, could be a new drug, it could be a new vaccine, a new diagnostic, a new public health insecticide for curing things like malaria.
Okay.
So all of those I would sit under that therapeutic umbrella.
Right. And you said the system's broken. So what's an example? In what way is it broken?
So many years ago, it was obvious, take the extreme example, I suppose, of the public health insecticides, that we had no new public health insecticides brought onto the market for at least 25 years.
Yes.
And that was because the agrochemical industry was actually looking very narrowly at what it wanted in agriculture rather than thinking about the health benefits.
Right.
And the target product profile for the public health insecticides had moved away from an agricultural insecticide. So effectively, the pipeline stopped. You may say that's an extreme example, and I guess it is, but I could make exactly the same argument for antibiotics. We started to use antibiotics as a commodity. The amount of profit then that was in those antibiotics was very limited. An industry driven by profit stopped actually filling that antibiotic pipeline. And so again, not enough new antibiotics coming in, and we get to the point where resistance is reducing the opportunity that we've got to be able to treat different diseases or different infections.
That's very interesting. Well, thank you, Janet, for the helpful clarification there. So you mentioned the grand challenges. Could you elaborate a little bit on that? Are you involved in a grand challenge right now? What is that?
Oh, absolutely. So I see no reason in just talking about these things. And I guess many years ago decided that it was up to me to try and do something about that. And so I did start around 20 years ago, trying to fill the pipeline for new public health insecticides
Hmm.
with a product development partnership with industry, which has been quite successful, and we're filling that pipeline.
Right.
But I then realized that there were issues, as I've said, in drugs, vaccines, and antibiotics. And
Yes.
so in September of this year, set up a huge new initiative to try and speed up that pipeline for those other molecules that we weren't dealing with earlier.
Right. Well, that's very interesting. I mean, once again, for the sake of our audience who might not have an exact background in the pharma industry, you talk about the pipeline of drugs. What is the problem? I mean, right now, for the average citizen, you have an ailment, you go to the doctor, she prescribes drugs. Maybe you go to the hospital. After you leave the hospital, they prescribe drugs. What's the problem? Where is the gap?
So the resistance that is coming through to those drugs is the issue.
Okay.
And if you get resistance to the drugs, then clearly you get the treatment, but it doesn't work. And the physician then moves on to the next treatment. That's fine if you've got a very large number of potential drugs that you could use to treat something.
Okay.
It's not fine if that drug is your first line treatment and it's your only treatment, and that's true for many infectious diseases.
Right.
And so you get stuck with something that no longer works.
I see. And that's the environment where you need this larger pipeline. Is that right?
I think it's true across the board, because any infectious disease, as you're treating people, what you're trying to do is kill that infectious agent.
Okay.
And if you're doing that, then selection pressure kicks in and resistance will inevitably come through. It
Right.
may not come through immediately, but it will come through over time. So, no drug, no vaccine, no insecticide is actually going to work forever.
I
It
follow
will
you.
work for a limited period of time and then it will fail. And so
Yes,
we need to continuously replenish the pipeline. Otherwise, we end up with nothing at the end of the day. And
I
that's dangerous
understand.
for everybody.
Yes, exactly. That's a very, very helpful clarification. Thank you. So, talking about vaccines, obviously, right now we're going through a terrible crisis around the world. We have the current pandemic, which is an absolute disaster. But thank God, from my personal perspective, thank God for science and scientists and public health. Tell us a little bit about vaccines and your involvement in them, and help us to understand, for those of us that don't work directly in public health or epidemiology, um, what are the concerns that we read about regarding, for example, new variants of viruses and this type of thing?
So I'll start at the beginning of the story in many ways, because I think the COVID pandemic has been an excellent example of how we can speed up
Yes.
that pipeline from early stage discovery to getting a new product out to the market.
Okay.
And we've done that. We've done that now multiple times with the COVID vaccine, truncating the time that it would normally take to get something like this through,
Sure.
from probably 10, 15 years to 18 months to 2 years,
Very
which is
impressive.
an astonishing sort of ability to take things through, and exactly what many of us have been saying we could and should have been able to do.
Okay.
So now we've got that. I'm really hoping that what doesn't happen is we slide back to the old ways of doing things
Hmm.
and back to needing to take 10 or 15 years to take something through,
Hmm.
because it isn't just COVID that requires new treatments through, it's many other diseases that do as well.
Okay.
Having got that, I think COVID is also a great example of a virus that is going to mutate fairly regularly and routinely. So, unless we can push it to extraordinarily low levels in the human population, we're going to have to deal year on year with new variants starting to come through. Now, that's happening quite quickly at the moment because we've got such a
Sure.
great amount of transmission going on. But even when we get the transmission damped down, it's still going to happen. The variants will just come up less frequently. And so, what we need to be able to do now with the vaccine pipeline is make sure that, in the same way as we do with flu, we get the vaccines to deal with the new variants as they arise, we don't wait for another pandemic to trigger and then have to start that sort of process.
I follow you. No, that's
And I
very,
think that's possible, but it's going to be a lot of work and it's going to be a lot of energy. And we're going to have to work out what the variants are that we need to worry about, what the current vaccines will handle. And clearly they handle some of the variants that are out there. They look as if they're not handling some of the variants quite so well.
right.
And so I think globally, there is going to be a requirement for tracking the new variants as they come through, working out what impact they have on the current vaccines and on
Yes.
our vaccinated populations,
Yes.
and then making sure that the global community is developing the new vaccines for the new variants that it requires and getting those out to the populations that require them. And that's going to be a tough ask over many years, I think, from now on.
Indeed. Yes. I think that's an understatement, but I certainly agree with you. So, Janet, what has actually changed? Why did it take 10 or 15 years for the journey from vaccine discovery to testing to regulatory approval to distribution? What else is in that journey? And why has this changed so dramatically with the advent of the current pandemic?
So I should also start by saying, although it has changed dramatically, a lot of the background work for these new vaccines had already been going on for several years.
Okay.
So we didn't start from ground zero in terms of developing these vaccines.
Yes.
But a lot of people had been talking about these new vaccine formats and the fact that they really should work. We didn't have the experimental data until very recently to demonstrate that they did work.
Right.
And looking at the speed at which we could develop them, the speed at which we could test them,
Yes.
and then the speed at which the regulatory agencies would look at that data and make their decisions on that data. Now, nobody wants a system where what we're producing are drugs, vaccines, and other therapeutics that are not safe. And so there is always going to be this balance between the amount of data that you need to generate, the amount of work that you need to do, and how you need to do that in order to actually satisfy the regulatory agencies that this is something that is safe to put out into the population very broadly. But I think we've seen from what's gone on here that by everybody working together, avoiding those regulatory hurdles, making sure that the early stage activity to develop the new molecules is speeded up, making sure that the clinical trials are set up in multiple sites simultaneously, that it's all very carefully handled, all very carefully managed, and that data then feeds through into the regulatory system very quickly, is clearly what's happened here. I think there's another stage, and we and others are starting to look at that at the moment, to find out whether we can move COVID vaccine development through into the human challenge space. So up till now, everybody has used the standard clinical trials that have been used going for vaccine development. I think there is an argument here, given the speed at which we're going to be able to look at or need to look at new variants and get new vaccines through, and the fact that we will have hopefully a fully vaccinated population that we're dealing with, which means we can't do the trials in the same way, to see whether there is an easy route of getting a human challenge in there quite quickly. But we and others are also looking at whether we can look at organoids and do some early work on humanized organoids, so that we know that we pick up things that are not going to be particularly safe quite early on.
Yes.
And so there'll be a paper coming out very shortly in one of the big scientific journals where we've effectively got a functioning, let me call it a functioning lung for simplicity, in a test tube, which behaves like a human lung would. we can use that to actually test some of the new drugs, new vaccines, other molecules that we're wanting to get through. And it's a much more efficient way of testing than the standard sort of microtiter plate testing that you do, that is an awful long way from human cells and multiple human cells all functioning together as a human organ would.
Yes, yes. This phrase or this word, what do you call it? Organoids, is that right?
That's correct.
Yeah, could you elaborate on that? Because once again, it might be the case that some of our listeners don't have a familiarity with the development of organoids and where we are in that and the future there.
So what we're wanting to do there is rather than take an actual human organ, which clearly we wouldn't be able to do, to set up something that looks and behaves exactly like a human organ would, having all of the different tissues in there and functioning as close as we can get it to the point that organ would function. And so for the lung, for example, we have multiple layers of different cells, and the upper layer of the cells is exactly like the lung surface and has beating cilia like the lung surface, so that we can actually use that artificial system to actually treat things in. We've got something similar for skin. Something that looks like human skin, and something that looks like a human liver, so that we can work that way. And I think in a relatively short period of time, we ought to be able to mimic all of the human organs in a format that would allow us to do these very rapid tests very quickly, very early. It should also allow us to reduce the amount of animal testing that we need to do. We won't get rid of it altogether, but clearly will allow us to reduce some of that. And by using a human organoid, you should be closer to the human being, and there should be less risk at that first big jump when you have to go into a real human than there is jumping from an animal model into a human.
Yes, exactly. Well, that's extremely interesting, and great to hear about the developments in that area. Just taking a step back, Janet, looking once again at the current pandemic, sometimes you hear the phrase bandied about moonshots, and the analogy is that where there's a will, there's a way, and that the United States government, of course, committed in the early 1960s to land a man and return them safely to the moon within 10 years, and they spent an extraordinary amount of money and political willpower and resource to achieve that goal, which otherwise, of course, could not have been achieved in the short amount of time. Is there a big theme here regarding the transition that has occurred in the achievement of the vaccines for the pandemic currently versus the historical timetables regarding vaccine development? And are there some big lessons there that we can be championing and holding on to, big lessons maybe outside of science in this area?
I'm not sure I'd call what's happened here a moonshot. So a moonshot to me is something where you stretch things almost beyond the believable and really push science right at the very edges of its boundaries to actually do something like that. And that would be, the equivalent of putting a man on the moon. I think what's happened with the vaccines and what many of us are arguing needs to happen, not just with vaccines, but drugs and other things, is to actually bring the technology up to date. So we've known for many years that we could speed these things up. We've known how we ought to speed these things up. There hasn't been the political will and the funding to do it. And so I'm hoping now that people will learn from what we've seen from the COVID pandemic, that there are better ways of doing these things. And we ought to be doing this, not just for the COVID vaccine, but for all of the infectious diseases that are out there. And not just for the infectious diseases that are going to hit people in the US and the UK and Europe, but also tackling those infectious diseases that are more prevalent in low and middle income countries, where the amount of funding that goes into developing treatments and vaccines for those is way, way lower than it should be proportionately to the health impact that is there. But we've demonstrated what we can do now.
Yes, no, that's a very good point. The theme of in health is unbelievably important and comes up frequently in our discussions. What are examples in the developing world where there's inadequate funding, and what are examples of some of the diseases or therapeutic areas that need attention there?
There are plenty of them. Having worked in this area, I'm going to rattle off a few terms that may be unfamiliar with many people. But schistosomiasis, for example, we have really no sensible drug treatment. Visceral leishmaniasis, we're working with very old drugs, which again, not great. Even malaria, although the drug pipeline has been re-stimulated with the Medicines for Malaria venture,
Yes.
we still have a requirement to keep that pipeline moving,
Okay.
because we've got drug resistance coming through.
Mm.
And so many of those tropical diseases or neglected diseases that sit in that basket really either only have one treatment that is usually very old and not very good,
Yeah.
and maybe failing, or a few treatments. But we could do better on many of these,
Yes.
if there was the time and the energy and the effort put into them that goes into other activities.
Yes, absolutely. Well, interesting to hear about these things. And we certainly hope that, for example, the work that you're doing and the brilliant work that many people around the world are doing in response to the pandemic will be a stimulation for a new approach to these challenges. Janet, we'd love to hear a little bit about your background and some of your areas of expertise. If you don't mind, maybe share with us a little bit about your career.
Oh, sure. An unusual one, I guess, like many people. I started life as a geneticist,
Okay.
and that was many, many years ago, when molecular biology was in its infancy. So we were still working with the lac operon and doing little bits and pieces like that.
Right.
So that huge shift had not occurred. But I was fascinated by that at a fairly early stage. Started looking at a project on Drosophila, which was the fruit fly, which everybody works with as the insect model for genetics, or did
Yes.
then.
Yes.
And somebody came and gave a talk about mosquitoes. And I thought, why am I going to work on Drosophila that really doesn't kill anybody and really doesn't do any damage to anything?
No.
Why aren't I thinking about working on mosquitoes that are clearly killing? At that point, they were killing around 3.5 million children every year. Thankfully,
Wow.
these days they only kill 600,000. It's 600,000 too many, but
Making
and
progress.
so I then did an undergraduate project on mosquitoes, got to know everybody in the UK who worked on mosquitoes, which wasn't very many people.
Right.
Was offered a PhD in that area, and looked at resistance to insecticides. Was then offered a job in the US, as I was just finishing off my PhD.
Right.
So I went to the US and worked for a few years there.
Okay.
Came back to a Royal Society fellowship, still working on insects and the insecticides.
Excellent.
Took over running one of the two schools of tropical medicine in the UK almost 20 years ago.
Wow.
And split my job between running the school and quite a big admin role, and still doing my normal sort of lab work.
Yes.
Then 15 years ago spoke to Bill Gates and literally was helping them put together their strategy for malaria.
Wow.
As part of that, understood that we needed to do something about public health insecticides. So he threw down the challenge to me that I needed to engage industry and do that. So for 15 years, I ran the Product Development Partnership, IVCC, which was and still is a subsidiary of the Liverpool School.
Okay.
I set it up that way, and we got the pipeline of public health insecticides moving. And then 18 months ago, I decided it was time to step down as director, and have more fun with the science before I retired.
Right.
And put in a bid to look at how I improved the way that we developed drugs, vaccines, diagnostics, and antibiotics. That was funded in September of last year, with 18 million of government money, but we've since expanded that out into a 178 million pound program in the last 6 months. And it's growing like crazy at the moment as we get many of the big drug companies coming in and working with us on key points in the pathway to actually get these moving.
Yes, so that's extremely interesting. What a fascinating career you've had, and congratulations, obviously, on all the impressive accomplishments. What's the name of the organization currently that you're leading that has done this fundraising?
ICON, that's ICON with a double I in the front of it, the Infection Innovation Consortium. And it's a mix of academics, NHS, health trusts, and large and small industry. So we have a number of core partners, 6 core partners, and then we have about 120 companies of various sizes internationally who are working with us as we start and develop this program and take it forward. So we're hoping for some exciting things over the next few years.
Sure. Yes, tell us a little more about ICON, please.
So it's modelled on the same sort of structure as I've set up for the public health insecticides, in that it's completely about translational research and goes from very early stage discovery. So, for example, we've set up a platform with a huge natural product library that we're just fractionating at the moment, never been screened for anything. But we know there are a lot of interesting things in there, because what we have done as we've taken the isolates of these natural products, we've checked whether they have any interesting antimicrobial activity.
Yes.
And many of them do have really, really interesting antimicrobial activity. So by fractionating those out, we're working with AstraZeneca and Unilever using an industrial scale screening platform, and starting to look to screen these for new antibiotics and new molecules that might go into the personal care and hygiene products through companies like Unilever. But the idea is there to have that as a massive screening platform that many companies who may have different interests and different activities can come in. That's at one end of the spectrum. The other end of the spectrum, we have a platform working in Malawi, Uganda, and the UK with the ministries of health in those countries, or with Public Health England and the Environmental Agency in the UK, where we're looking at the best place to put products to reduce the amount of antimicrobial resistant bugs or COVID virus that gets into the environment. And that may be that gets into water courses or other parts of the environment, so that we can reduce the spread of this around the environment. And we're getting some really interesting results there as well already, that the ministries of health in the countries that we're working with are already utilising to change policy in terms of what happens in hospitals, in healthcare, and in care homes, for example, or in agricultural units, where a lot of these are shedding hotspots for resistant microbes or for COVID virus. And if we can actually reduce that shedding, then again, it's going to be beneficial for everybody.
Absolutely. Yes, Janet, that's extremely interesting. Could you elaborate on that last point that you were just making? I don't understand this idea of what you've got physical hotspots where the bugs and the viruses and the germs kind of camp out more than other places. And is that right? And what's the challenge? Identifying them or isolating ourselves from them?
So it's not that they. For example, in care homes and hospitals right now, we know that there are a lot of people who've got COVID virus. And so it's then a question of, okay, how does that COVID virus migrate out of that hospital or out of that care home? We know that it gets into wastewater. And so the question is, how long does it survive in wastewater? And if we put something in the care home, for example, that is going to reduce the amount of virus that's shed into wastewater, is that actually going to reduce the amount of transmission and the way that it gets passed around society? Equally, if you're dealing with a hospital, where is the virus coming from? How is it getting into the environment? Or from an animal farm where you're treating animals with antibiotics, we know again that resistant bacteria get into the soil, get into wastewater, get into the environment. are there things that we can do that reduce the amount that get into that environment and therefore reduce the amount of spread that we get?
Yes. Okay. No, that's extremely interesting and such important work. It just reminds me, who was the famous, I guess sometimes people consider him the father of epidemiology in London, in Soho in the 1950s, who discovered was it hepatitis B was in the sewers?
Yes, that's right. And we've also got people who were looking at what was going on in drinking water even before that,
Yes.
and people working out that some of the infectious diseases that were spreading in the UK 100 years or more ago were happening through drinking water there or through the sewers and things like that. It's
Yes.
exactly the same thing. We're almost learning the same thing again.
Oh, that's interesting.
But with a new virus, which we need to think about, or with drug resistant bacteria that we clearly need to stop spreading.
Yes. Yes. Yes, absolutely. Well, look, Janet, all of this is unbelievably interesting, and I'm only sorry that we don't have a few more hours to discuss this, and I wish we were sitting in the beer garden of a nice pub and I could buy you a drink and we could continue this extremely interesting and informative conversation. But we have a few minutes and then we'll wrap up if that's okay with you.
That's fine.
Regarding ICON, it's so interesting, and congratulations on what you have accomplished there. We're proud to have you on board here and to hear more about it. Do you guys have any asks to our international community? Are you recruiting? Do you have papers coming up you want to publish that we can help you with? Are you looking for additional members? What would you like to share with our community regarding some of your goals for this year?
So I think have a look at the website. It should be relatively easy to find. We're relatively new, so it's getting populated day by day as we go along.
Right.
But what we want is that if people are out there who have a new drug that they want to progress, or they're thinking about developing new antibiotics, or they've got products that they're thinking, where do these belong in the market, or they want better ways of testing them, or a new diagnostic that they want to look at how they validate or how they take through more quickly,
Okay.
then we may be able to help. We are happy to talk to people, see how we can interact. And what we want really is, with a lot of these things, to change the regulatory environments longer term.
Yes.
And so this means it can't just be us doing these things this way. If there are better ways of doing these things, then everybody needs to do them better. And having demonstrated that we can do something better, we need to get that embedded into the whole system.
Exactly.
So the bigger this population is and the more that we collaborate and work together to do that, I think the better for everybody in terms of taking that forward.
Absolutely. No, agree 100%. And I hope in some small way we might be able to help and support that through our international community. Remind us, Janet, please, about the website.
It's www.icon.org, I think. But if you put ICON into the browser, you will find us.
Excellent. And it's IICON, double
IICON. That's correct.
Excellent. Well, look, this has been such an interesting conversation. And Janet, I know we don't have any time left, but I'd like to thank you on behalf of everybody in our international community. Thank you for your time. Thank you, of course, for the extremely interesting conversation we've had and the great information that you've shared with us. I've learned a lot already, and I really appreciate that. Thank you very much.
My pleasure.
Likewise, of course, I'd like to thank the rest of our sponsors for this week's episode of Giants Healthy Innovators Live TV. Thank you to our sponsors, McKinsey, who's our knowledge partner. Thank you to Vodafone Business and Barclays Bank Eagle Labs. Once again, my name is Barry Shrier, and I'd like to invite everybody once again to come and join us at European Health Tech Innovation Week. That takes place next week from Monday the 17th to Friday the 21st of May. European Health Tech Innovation Week is 5 one-day conferences taking place in Liverpool, Berlin, Paris, Stockholm, and Barcelona. The first event on Monday the 17th of May is a real-world live event. It's the first event taking place in the UK following the relaxation of restrictions for the COVID pandemic. So the British government has allowed us to get back to work, to open up our doors and to have events again. So on the first day of this permission by the UK government, we're running European Health Tech Innovation Week on Monday in Liverpool. Janet, looking forward, in fact, to seeing you there. So thank you once again. And thank you to all of our listeners from around the world. we're very keen to support you, so don't hesitate to contact us. Our website is www.giant.health. Look forward to hearing from you, and thank you once again. Good. Okay, Janet, that was absolutely superb. I know I took up a lot of your time, but this was incredibly interesting.